Hi, in this video I want to show you how to find the amount of charge in an object using Coulomb's law. So let's say we have two equally charged slices of aluminum foil. They repel each other with a force of 15.0 newtons when separated by a distance of 5.25 centimeters. Calculate the amount of charge for one of the slices of aluminum foil. So I've drawn a picture here and I've represented the slices of aluminum foil as point charges. They are repelling each other with 15 newtons of force when they're separated by this distance. So I'm going to go ahead and substitute in things that I know down here. I did want to note 5.25 centimeters. We need to, if we want our force to be in newtons as it is here and all the units to work together, this needs to be converted into meters. So we're going to divide by 100 and that'll give us a distance of 0.0525 meters. Now for the charges, we're not given how much charge there is for either of the two. We just know that they have an equal amount of charge. So Q1 and Q2 both equal the same amount of charge. To make this work algebraically, to simplify our problem here, we're going to need to indicate somehow that they both equal the same amount of something. We don't know what that something is though, so we're going to use a letter instead of a number. So Q1 and Q2 both equal, we could say they both equal X, they both equal Y, or we could just say they both equal Q. We don't know how much charge there is, but we know that there is a charge, and that charge is Q. So by doing that, when we get over here to our Coulomb's law equation, we're going to simplify it a bit because Q1 times Q2 is both just Q times Q divided by distance squared. And Q times Q, we can simplify that even further and just say that's Q squared. Okay, so now that we've simplified this a little bit, now we can start to substitute in and solve for this missing strange Q value that we don't know. So I'm going to substitute in my force, which is 15 newtons. K is 8.99 times 10 to the 9 newtons times meter squared over Coulomb squared. And then we of course don't know what Q squared is. We're going to be solving for that, but the distance is 0.525 meters squared. Okay, so we have a lot here and we're trying to solve for Q, but it's kind of difficult to solve for it right now. So just a little algebra review. We need to isolate Q, but to do that we need to kind of move these other things out of the way. The first thing that we're going to try to get rid of is this denominator. We want to get rid of fractions first, and so we're going to try to first just square what's in the denominator here. So I'm going to leave everything else the same. And then I'm going to square the denominator. So square 0.0525. So after doing that, that gives us 0.00276. So I could write this in scientific notation, but I don't know if that's any easier, honestly, at this point. So that's the denominator now after it's been squared. So now we need to get rid of the denominator, undo the division here. So we're going to multiply both sides by this denominator. So it's going to look like this. We're going to do that to this side as well, the other side of the equation. Oh, I'm missing a parentheses sign there. Oops. So doing that, I'm going to have on this side, it's going to be 0.0413. And that's newtons times meters squared right now. And then I'm left on this side with 8.99 times 10 to the 9 still. And this meter squared over here, these all canceled out. So that's just going to be multiplied by Q squared. All right, and then now I'm going to undo this multiplication here. So I'm going to divide both sides by this K value. Make sure that you put parentheses in when you're using your calculator here, or else you may not end up dividing by the whole quantity. So doing this division gives us a number value of 4.5 or 4.60. And then the units here kind of get a little crazy. So we have newtons times meter squared divided by newtons times meter squared, and that kind of goes away. And then the Coulomb squared gets flipped up to the top of the fraction here. So it's just Coulomb squared there for Q, which you can see that's going to be what we want, because now we just need to solve. Sorry, I should have crossed this out, so that goes away. All that's left here is Q squared. Now we just need to solve for Q by undoing the square, so we're going to do the square root on both sides here. So doing that gives us a value of the charge. Oh, I'm sorry, oops. You couldn't see what I was doing. So that gives us the value of the charge of 2.14 times 10 to the negative 6 coulombs, which, we could rewrite this as 2.14 microcoulombs as well. So that's all I've got for you in this video. Remember, shortcuts make long delays.